Hello and welcome to another free code session. My name is Jason Bach and this is going to take 5 episodes just because I have no idea why. I've already done one and I'm hardly even done with it yet. So I know my trending. I've also got some liquid courage going on. So that's a good thing to have. At least I'm fine with it. So, but if you're not, that's totally fine too. Absolutely fine. Do what you love. That's my motto of, well, at least it's a motto of my life. Anyway, I love coding. Let's get to coding. I want to do a couple tests on this just to make sure that this is working as expected. This is day 24. Can I count? Probably not. So what we want to do here, say fact. Why did I use xUnit? I don't know why I used xUnit for these. Yes, sure. Maybe. What do I want to do this one? Parse, optimize, one grid. Even distribution. Sure. Whatever works. Our input is equal to new array. And we're only going to have one element in it. Well, one row. Down. It's 8. That's what we care about. Okay. So now we're going to say, oh God, our grid, not GUID. I keep saying GUID. SD24 input. Except we want grid and length. I think that's what I was calling it. X length. Sure. Assert single grid. Assert. I want to go through this whole thing now and do unit. I don't know why I was doing this as xUnit. Oh, let's make that an L there and then we'll say, I'm assuming that the length would be 8. X length. And, we're going to pull that ton. Oh my God. Do that, and then we're going to say assert equal. Now, we can test these by bits. Right, 0B. So, let's come here. I said up. Up. There, jeez. Okay. So the first one, the 0th one, is to the right. I can't code. So it's going to be far underscore no 10, right? Because yeah. Now those are the grid 0 because that's the X 0. Thank you. I'm assuming that just, because I thought that was a prop. Who knows? That was in the last episode. That's ancient history anyway. Okay, so that's the first one. The second one is going to be another set of these. Okay. Now the third one is all zeros. And the fourth one is a left. What is a left? That's the 0 most. Whoops. What? Jeez. 0, 1. That's what this should be. Now there is another row. Oh, that's gonna fail. That's gonna fail. It's not single. There's 2. Yeah, it's not single, is it? It's gonna say but it contained 2 elements. Yes, equal to grid length. Right? Yep. Good. Okay. So let's see if this works. It doesn't. It doesn't work here. Well, it's close. It's close. So that's right. And yeah, that's 1 0 1 0. We got nothing there. And then to the left should be 1. Only it's down at the bottom is not. How do you, hold on. I forgot how to do stuff. So let's do build. Are we in? No, we want to, well, we want to be in is debug. Okay, so let's debug this. Okay, so we're here, and what we want to say is convert to string grid 0, 0, 2. Wow. Oh, yeah, that would be a problem, wouldn't it? Like parse, optimize one grid. Because we keep setting this, we want to AND it with what it currently is. Not AND it, or it. Yeah. So that's why the topmost one worked. Although, what actually is this? I can't read binary. It's just a bunch of 1, 2, 3, 4. And then, yeah, that one is the lowest one. So I think we just have to OR it in, and that's what we're missing. Okay, well, see, glad I did this now rather than forgetting it. So we want to say that or that. Yep, come on. There you go. And you too. Although, that, because now we don't need to do that extra calculation. That's not even needed. We just keep what's currently there. Awesome. So now, if you run this, it passes. Wow. When you write code correctly, it's amazing that your code can pass. Okay. So the first one is going to, oh, geez, all the way at the top here. It's going up, right? So 1, 0. And then the next one's going down, which is the topmost bit. And then the next one is nothing, and that one is a write, which is the second 1, 0. Except this is grid 1. Let's see what this does. And that passes. Good. Good, 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 good. Now, let's just say we put in a extra one in there. The X length is going to be 9. We're going to have 3. These two are still going to be the same, but this one is going to have what is up, which is the third most bit. Yes. And then the rest of these are all zeros. Uneven distribution because reasons. And good, 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 good. Okay. So we got that going for us. So now if I come to one grid, I say one grid there. Yay. Why does that suddenly not work? There's no get. Oh. It's like, of course it's going to work. It doesn't matter if it's a uint. It's because I'm returning a tuple. Don't you remember where you just coded, Jason? Now, we don't make a new grid. Okay. So that's the first part. We don't make a new grid. This is what we call fun. What we want to do is we definitely want to say, go through all the Y's, and we want to go through all the X's. But within the X, we have a maximum of 4 and at least 1. What we're trying to grab out of here is that value. And now what we need to say is for var b is equal to 0, b less than, and this is where I think that X length is going to come into play. Let's do the case of 101. If I had 101, I take X length, so we're going to put this in parentheses here, minus max X times 4. because each one contains 4. So if I had 100, max x would be 25. 25 times 4 is 100. And so we would never go through this. Right? But we should have never gotten to this point. If that occurred, we should have never made a 26 element that had nothing in it. But if we did make a 26 element, then we'd have 26 times 4, which is 104. So we want var b limit is equal to if x length is greater than this, because we would have on the 25th element, we'd have 25 times 4 is 100. And so we'd want it to be a mod. So we want it to be 100. Ah, yes. Okay. Sorry. I think I just got this in my head. So now if we hit 26, it's going to be 26 times 4 is 104. No. That's I'm not thinking the right thing here. Max x tells us the length of it, so that'd be 26. X length is actually going to be like 100. Now, if it's 100, sorry, I've probably been spouting, just babbling stuff, and you're like, what are you trying to do? I'm just trying to get in my head how I do this so that it's always the right bits that I'm looking at. And so if I have a length of 100, that means max x is 25. So as I go through this, it would be not max x, it would be x there. So it'd be 0 times 4, 1 times 4, 4. 100 minus 4, except again, this is where that mod thing in C# doesn't actually do what a mod should do. We want this whole thing to be 4 minus that expression mod 4 b++. That's how we determine what bits we're at. The 0th, the 1st, the 2nd, or the 3rd. But this could become 26. So this is where if it was like, yeah, because x length, where's x? That's the total length. That'd be like 102. But that's not, yeah, I think I got this in. Var b limit is equal to if x length is greater than x times 4. If that's true, then what we want to do is go up to 4 because that's the limit, okay? Otherwise, it's going to be x times 4 minus x length. So virtually all the cases, this is always going to be greater. I'm sorry, not a question mark at the end. There we go. And so that's b limit. Right, okay. So the x length is the total length. Be 100 is greater than 25, greater than or equal to. So 125 times 4 is 100 equal to, yes, we do all 4. If we had it where it was 102 and what we had was 104, it'd be 104 minus 102. And that would give us 2. So we go 0 and 1. Yes, I'm almost positive now I got that right. Okay. So what does this tell us? Well, a couple of things. If blizzards, if blizzards and SD24 blizzard direction right, in other words, and I am looking at the current direction, we're finding out the new ones, and then we're going to push them down with that little mask trick. Okay. I also have to do that thing here, like what I was doing down, where was that? this. Except that's how much I want to push it over. Right? And solution day, except you want to push that over B. If that's greater than 0, I didn't do something right here. Operator and cannot be applied to, well, this is what I want. There you go. Okay. So if that's true, we go right. Now, how do we go right? Once I figured this out for one, I think right and left are the tricky ones. Up and down, not so much. Famous last words. So this is saying, oh, no, you have to push it over, not just like 0 or 1. This is B times 8. Right. Because down here, yeah, we were doing that times 8. We need to push that over times 8. Okay. So if we AND it with that flag, and that flag was turned on, that means we are now taking that blizzard and we're going to move it over to the right. Except here's the tricky part. Either we're going to move it over to the next set of bits, or we're going to move it over to the next element in the array, or we've actually are at the end of the array. Either we're at the 4th set of bits, or we're at the last set of bits. And now we have to go around and go back to the beginning. So we can't just do like x plus 1. That was the easy thing. We have to be a little bit more cautious here to say, how do we know what the actual right movement is? And I'm going to leave that for the next episode because this stuff is tricky and I need to think this one through a little bit. So we're going to hold that off until the next episode. Thank you all for watching. Leave comments and questions below. See you in the next episode.